Hey, Algebra 2, here is 13.2. We are defining general angles and using radians. Um, so that's pretty much the basis of our objective is to define/measure angles in standard position. We'll talk about that in a little bit. Define the radian and measure using radians, and then convert back and forth between degrees and radians. Okay, so pretty much the general idea of this section is to use angles, kind of measure them in the coordinate plane, and to just kind of give us a little bit of a setup for pretty much what we're going to be doing for the rest of this section, okay? And so before we get started, just kind of a little bit of a tiny review about angles, right? So an angle, we have a vertex and two rays. Okay, a ray is just a line that only continues in one direction, right? It's not two directional like a general line. And so an angle is kind of the measure of the wideness, I guess, of the distance between those two rays, okay? And so we measure an angle like so. That's one example of an angle. Another example is like this, right? We have obtuse, right? Acute angles, that kind of stuff. And so pretty much what we're going to be doing in this section is measuring angles, but now we're going to put them in the coordinate plane. And when we put them in the coordinate plane, that kind of lets us do a lot more with angles than we could with just the vertex and the two rays. Okay. And so here's kind of the idea of what we're going to be doing. So before, let's just kind of remember what each of these quadrants are. Remember, it's quadrant 1 here, quadrant 2, quadrant 3, and then quadrant 4. Okay, kind of a counterintuitive direction, right? We'd probably think like, I don't know, 1, 2, 3, 4, or kind of another way, right? But this is the direction of the quadrants 1, 2, 3, 4. And so what we're going to be doing is we're going to measure our angles in standard position. And what that means is we're going to put the vertex of all angles, any angle that we measure on the coordinate plane, we're going to put the vertex here at the origin. Okay, we're going to put one side on the x-axis, and that's actually going to be called our initial side. Okay, so this is known as our initial side. And the initial side is always, always, always on the x-axis. Okay, and then I'm going to measure the angle. Let's say that I want it to be this. Let's say that this is my angle. This right here, this is called the terminal side. The terminal side is the one that can move, that can end up in different places. Okay, this is known as the terminal side. And then I need one more thing. I need to indicate which direction my terminal side went, because in the coordinate plane, I can actually measure positive direction, and I can also now measure the negative direction, okay? If I go in a counterclockwise direction, so going against the clock, in this case, this direction, then that's going to be a positive angle. I'm going to do that in a different color. It's going to be a positive angle. Let's just call it theta for now. Okay, and so we use this right here to indicate the direction of the angle. So indicates direction. Okay, every time we measure an angle, we're going to need to do the vertex, the two rays or the sides, and then the little arrow here that indicates our direction. Okay, because I could have either went this way, or a different angle would be if I went this way. Those are completely two different angles. Okay, so it's always good to indicate your direction. And then another piece of information to know as we measure angles on the coordinate plane is that our axes kind of mark some really nice angles for us. Kind of imagine that there's a big circle on this coordinate plane. How many degrees are in our circle? 360. Okay, so if I start here, this is my 0 degree mark. I can have a 0 degree angle that just looks like this. Okay, that is a 0 degree angle. If I go from here to here, if I have something that looks like this on my coordinate plane, then that's going to be a 90 degree angle. Okay, if I do something that looks like this, sorry, I didn't indicate direction in this one. something like this, then that's going to be 180 degrees. So right here would be 180 degrees. And so then we can kind of guess this will be 270. And if I make a complete circle, then that's going to be 360 degrees. Okay, and so that's why it's important because to indicate the direction, because this right here is 0, but this is 360. This is 0 degrees. This is 360 degrees, because you're telling me that this angle went, you can kind of think of as one ray would be the orange, the initial side would be orange, and the terminal side is blue. Okay, that's two sides lay on top of each other in this case, but in this case, they also lie on top of each other, right? But it's kind of important to indicate that direction, that way you know the difference between the two. Okay, in terms of drawing, not going to be a huge like deal, not important, but sorry, I said that incorrectly. In terms of the stuff we'll do later on in the week, not going to be a huge deal, but for the purposes of just drawing and telling me the angles, then it's really important to make sure you indicate the direction. Okay, so let's summarize what we just talked about a little bit. So standard position is going to be the most important thing to summarize. So standard position, what does it mean for an angle to be in standard position? Okay, there's a few things. The first thing is that the vertex of the angle is at the origin. Okay, and so that just means that we're going to put that dot there. We actually don't even need to put the dot there, but just so you know the kind of the, I guess like the mouth or the throat of the angle, if you think of it as like a, I don't know, like Pac-Man kind of, right? This part is always going to be at the origin. Okay, and then the other thing is that the initial side of the angle, always on positive x-axis. Okay, so it's not enough to say x-axis, we have to make sure we say the positive x-axis. Okay, so what does that mean? That means if I have my coordinate plane, then my initial side is always going to be here on the positive side of the x-axis, the right-hand side. Okay, and then one last thing, or two last things, I guess, is that counterclockwise, okay, direction, so the counterclockwise direction means positive angle. The clockwise direction, so going with the clock, is negative, okay? And if you're not super familiar with like analog clocks, with like the circle ones that have the hands, right? If you're not really familiar with those, like you're more familiar with like the digital ones, then you can kind of draw yourself little directional arrows. So counterclockwise means this way. Okay, this is positive. That's an arrow, not a G, by the way. And then the clockwise would be this direction. Okay, and so that would be negative. Maybe draw that for yourself in case you have trouble with the clock. Okay, and so that's kind of setting the groundwork for just how can we measure angles. And so now it's going to be nice if we have some kind of like, you can think about it as like, how would I describe it? Just kind of markings that show us, okay, here is this angle and here is that angle. So then I know that if I'm measuring some weird angle, it's going to be between those two, right? Just some like markings that help guide us when we're drawing angles. And on top of that, these are going to be really important angles for us to know for the rest of the semester, and if you decide to go into pre-calc, okay? These are going to be really good angles to know and almost just kind of memorize, right? At least the angles. And so we already know a couple of them from what we just drew up above, okay? And so let's start there. I'm going to do those let's do them in red. So I knew that this was 0 degrees, my starting point. Up here, this is 90 degrees. 180 over here. 270 down here. And if I make a full circle in the same position is 360. Okay, so 0 and 360, same position, just different angle value, okay? Even though they look like they're different angles, or sorry, they're in different positions, they're both on this positive x-axis, okay? And so here are some of the other angles to go. And we're actually just going to come up with them ourselves. They're not coming from out of nowhere. That way you don't feel like they are, right? So notice that 90 is here. And we can think of it 90 being there because it's halfway between 0 and 180. Okay, and so we can get the rest of these by thinking about it that way. If you can't really tell, this marking right here is halfway between 0 and 90. Halfway between 0 and 90 is 45 degrees. Okay, these two are thirds of the way from 0 to 90. So this is a third, this is a third, and so then that would be a third as well. So a third of 90 is 30 degrees, and then 2/3 of 90, if I do 30 plus 30, that's 60 degrees. Okay, you don't need to focus too much on where they come from or like why. It helps a little bit to understand kind of why we're putting these numbers there, but you don't need to focus too much on it, right? As long as you have this nice picture drawn in your notes, you'll be okay. Make it as nice as you can, draw a circle on a coordinate plane and then make these little markings, okay? And so then we can come up with the rest of them by following that same kind of logic. And we'll just kind of go through them really quickly. This is 120. This is 135. Oops. This is 150, 180. And then we have 210 right here, 225 right here, 240. And then over here we have 300, 315, and then 330. Okay, all degrees that we can find in a circle, all kind of just part of this idea of measuring angles, right? So kind of what I was saying earlier, this would help us then if I ask you, okay, measure an angle that's 200. 200 is not anywhere on here, but I can guess that 200 is going to be somewhere here. I don't have to be exact. I just know that this angle will then end up being right here. Okay, here's my initial side, and then my terminal side right here, and then this is my direction. This would be about 200 degrees. Okay, and so this is kind of the point of this. It's going to help us to measure some other angles, and then it's going to help us a lot in the next few days when we talk about something called the unit circle. All right, so let's just use that as our guide for this first example. Draw the following angles in standard position. Okay, and we're going to draw some negative ones as well. We'll kind of see what that means in a little bit. All right, so to draw these angles, we're going to draw ourselves a little coordinate plane first. Okay, you don't have to, when you're drawing the angles, you don't have to redraw this entire circle. I'm just going to look for the one angle, right? So 250, if I look at my little guide here, here's 240 and here's 270. So it's going to be somewhere in this area, okay? So then I know my, oops, I moved too far down. There we go. I know my initial side is going to be right here on the x-axis because we talked about that with my vertex there. And then, like we said, 250 is somewhere there. So all I need to do is draw my terminal side in that general vicinity, okay? And then indicate my direction. So this is 250 degrees. And that's all there is to that, okay? That's all we need to do. It gets a little bit more involved when I get to angles bigger than 360, so 500. Let's go with that one. So 500 degrees, okay? So we know that this is going to be an angle bigger than 360. So I know I'm going to have to do one full revolution around the coordinate plane first in order to get to 500, okay? Well, let's think about it this way. One full revolution is 360. Okay, so I'm going to go one full circle and then however much more I need to get to 500. So how much would that be? Well, we just got to do 500 minus 360. Okay, and so that's going to be 140. So go one full revolution. I'm going to put my initial side here. Go one full revolution. Okay, there's my 360 degrees. And then I need to go to 140. So 140, where is that? That's going to be somewhere a little bit more than halfway in the second quadrant. Okay, so I'm going to put my terminal side like right here, and then I'm going to finish my directional arrow. Okay, make it look a little bit nicer. Okay, and so there's my directional arrow indicating that this is 500 degrees. Okay, so sometimes you're going to get this kind of like spiral idea, right? Where if your angle is more than 360, then I have to kind of keep going outward. All right, and so, if I think about like an angle like 1,000, that you're going to end up with a spiral that's kind of big, and that's okay, right? So just know that you might see that in some angles like on your assignment. All right. Okay, now let's do a negative angle. Negative 50 degrees. So we know we're going to have to go clockwise because it's a negative angle. So let me just put my initial side down right here. And I know I'm going to need to go this way. All right, my markings are kind of only in positive angles, but that's okay. I don't really need to remark this with the negatives. That'll just take too much time, right? So how can I think about it? Well, from here to here, so from 0 to right about there, that's my 50-degree point right there. So I traveled this much distance on the circle to get to my 50. So then I need to travel that same distance negatively to get the negative 50, right? In other words, another way you can think about it is measure the angle positively, then go across the x-axis, okay? So here's positive 50 right here. If I want negative 50, then I just go across the x-axis. Okay, and it works for if it's below the axis, right? So if I wanted to measure, say, like negative 210, well, here is 210. So from here to there, that's my positive 210. If I want negative 210, then my ending point will actually be right here. So then from here to there will be negative 210, but it'll be this direction. Okay. So it's always just a matter of going across the x-axis to get that negative one, right? So here is going to be positive 50. Okay, that's where my positive 50-degree angle is. If I want the negative 50 degrees, then I just go across, and that's going to be my negative 50. Okay, and now I don't need this one up here because that was just to help me. Okay, so if it helps, draw the positive version of the angle first, and then you can go straight across the x-axis to get the negative. So here is my negative 50 degrees. Okay, make sure you do that little directional arrow to show that you went clockwise. All right, and one last one, negative 400. Okay, so I draw my little axis first. I know I'm going to need to go a full circle because this is more than negative 360. All right, so I know I'm going to have to do one full revolution first. So if I'm going negative, I'm going this way. All right, here is one full circle. How much more do I need to get to 400 from 360? 40 degrees, okay? So 40 degrees, it's about this much. It's a little bit less than half, so I only need to go a little bit less than half, right? So right about there. I made the terminal slide a little too long. Let me fix that. Okay, so here's my directional arrow, and here is negative 400 degrees. Okay, notice how it went around more than once, and that's going to be okay. All right, so there's a little bit of measuring angles. Hopefully that makes sense. We'll do some practice with that in class, of course. Now let's talk about another way to measure an angle. All right, just like there's multiple different units for, say, measuring distance, like a foot versus a meter, right? A yard versus a meter, probably a little bit more of a better comparison. Just like there's different ways to measure in distance, there's different ways to measure angles, okay? And so one way to measure an angle is by using a radian. Just to kind of give you an idea, first, 1 radian ends up being approximately 57.9296 degrees, okay? This conversion factor is not going to do us a whole lot of justice, one, because it's an approximation, right? But this is just to kind of give you an idea of what is the radian and how much is it in terms of something that we know, right? 57.296 degrees. Where does that number come from? Well, it comes from the fact that here's kind of how we build a radian. So I have a circle of some radius, okay? The radius of the circle actually does not matter. And remember, the radius is the distance from the center to the outside. So that's 1 radius right there. So pretty much a radian comes from me taking the radius. Okay, here's the radius. Pretend like you're measuring the radius with a piece of string. And maybe it's too long, so you cut it off, and so you have exactly a radius length in terms of string. What I'm going to do is I'm going to take that string, pull it out, and actually I'm going to lay it on the circumference of the circle, right about there. Okay, imagine taking this little purple line right here, getting rid of it from there and putting it right here. Okay, and then I want to connect the center to where that ends right there. So right here. This right here, this angle that is created from kind of intercepting that arc on the circle, the piece of the outside of the circle, that right there is 1 radian. Okay, that's 1 radian in terms of an angle. And so let's just kind of explain what we did just now. So taking the radius length, right? So imagine putting a string there and then cutting it just right so it's exactly the distance. Taking the radius length and laying it on the circumference of the circle. Circle, not circles, okay? And so the angle that that process creates is the radian, all right? So now, how can we go nicely between radians and degrees? Well, like we said, this is not really going to work for us. This is an approximation, so I can't really use that to convert. Okay, a better conversion comes from the fact that our circumference of the circle, and if you're a little fuzzy on your geometry, remember that circumference is another word for perimeter, but we use that for circles. It's the perimeter of the circle, right? Remember that the circumference is, one way to think about it is pi times the diameter, but another way to think about it is 2 pi times the radius. So what is this saying? This is saying that if I took the radius length and put it around the circle, I can fit 2 pi of those radius lengths. And so because of that, that means that 360 degrees around the circle, because that's 1 full circle, that's going to be 2 pi radians. And we're going to abbreviate it as rads. This is a much better conversion factor from that because this is exact. There's no decimals, there's no approximation. It's exactly it, and we do not have to worry about rounding or anything like that, or making it so that it's not an accurate answer, right? An even better conversion factor, and this is the one we're going to be using, is dividing both of these by 2 because we have that 2 there. 180 degrees is the same thing as pi radians. Oops, my writing tablet is lagging. There we go. Here is our conversion factor. Okay, so conversion factor. This is what we're going to use to convert between to and from degrees and radians, okay? And so here's what we're going to do. I forgot to actually put in the examples here, so we're going to write them in. Convert from degrees to radians or radians to degrees for our last example. So we'll just do 2 here, 135 degrees. We're going to convert that, since it's in degrees, to radians. Okay, so let's think about how to get there. Okay, we're going to either multiply by pi over 180 or 180 over pi. And I should be putting the units here. Okay, so how do we know which one to do? How do we know which one's going to be the right conversion factor to use? Well, I'm going from degrees to radians. So if I want to multiply 135 degrees by one of these, I don't want to multiply by this one, because if I do 180 over pi, then I don't get rid of these degrees. I actually get degrees squared divided by pi radians. So now I have, so that would give me degrees squared over radians, and that's scary. That doesn't make any sense. So we need to make sure that the degrees gets divided out. So I need to multiply by that first conversion factor, pi over 180. okay? So always make sure that the units that you want is in the numerator. So if I want to go to radians, I'm going to use this one. So this is going to be from degrees to radians. And so then this means that this one is from radians to degrees. Okay, so what is this going to be equal to? This is equal to 135 pi over 180. Okay, radians, rads. And so now let's go ahead and try simplifying that value. Okay, 135 over 180. Well, I know 5 goes into both of them. Okay, so if I divide 5 into both, we're going to end up with 27 over 36. Okay, so 27 pi over 36. But then if you notice, 9 goes into both of those. So I can divide both of those by 9. I get 3 over 4. 3 pi over 4. Radians. Rads is my abbreviation. There we go. Okay, so 3 pi over 4 rads. And then we'll do one more example where we go backwards, right? So let's go from pi over 10 rads. And so here, this is clear, we're going to go to degrees. And so we're going to multiply by the other conversion factor, 180 degrees over pi rads. So pi over 10 times 180 degrees over pi. So the pi's are going to cancel because I got one in the numerator, one in the denominator. And I end up with 180 over 10. And 180 over 10 is nice. That's just 18 degrees is our answer. Okay. Kind of a long lesson. Okay, I do apologize for the length, but it's important that we set this foundation for the rest of the section. We're going to combine what we learned in the previous sections on, doing our trigonometry with those trig ratios, combine it with this to use something called the unit circle here in a few days. All right. Hope this made sense, y'all. Have a good rest of your day.